Ladies and gentlemen, once again, you are all cordially welcome to our analysis. Let me just remind you, we are going to do the Excel version of everything we've been doing so far, okay? We are going to formulate everything in Excel and solve it. The formulation in Excel is not my big deal. My big deal is your ability to answer what the Excel is giving you, to make sense of what is inside the Excel. Just remind ourselves of the information we have. This is Z-max. This is what we had before, okay? And we had 40x1 plus 50x2. I'm sure you all remember this. And this was subject to some constraint. And then we had a labor constraint, which is, I'll write it here, 1x1, I'm writing the 1 for a reason, plus 2x2 less or equal to 40. And then we had 4x1 plus 3x2 less or equal to 120. This was a formulation of the Farmer-Ghana Limited that we had some time ago, and I'm sure you all remember. Finally, we have the non-negativity constraint. Okay, we have the non-negativity constraint. Now, so how do we now write this, do this formulation in Excel? So let me just go to my Excel and watch me as I do it. So go to your Excel. And the first thing you want to type is the name of the company, Farmer-Ghana Limited. So Farmer-Ghana Limited. Just write it in the first cell, there. Okay. And then, yes, write Farmer-Ghana Limited, okay, in the first cell. So please do that for me. And then you write the name of the product, okay, the decision variables in the section called column B here. You write the name. And the first name was Yogo. The second name was Choco, Fan Yogo and Fan Choco. I'm using the actual names. Okay. I'm using the actual. Now the last section there, you write Z. That is going to represent the Z variable. Now, just below the Farmer-Ghana Limited, just write profit per unit, because what we are going to do is to put the profit per unit there. Okay. Profit per unit. So on its right, on the right section here, we are going to put the name of the profit per unit. What was the profit per unit for Fan Yogo? If you can remember, it was 40. Just to go back here, you will see it. It was 40. The profit per unit for Fan Yogo was 40. Okay. The profit per unit for Fan Choco was 50. I'm going to put it directly under each one. So under Yogo, we're going to put 40. Under Choco, we're going to put 50. Now, then just under the Z value, by the way, the Z value is a profit. Okay. So the Z is actually the profit, the total profit, or the objective function. So that is the profit or the objective function. Now, right now, we don't know what it is, so we'll come back to that. It's a formula. Just below the profit per unit, write the decision variables, DV. Decision variables, DV. Okay. Write the decision variable, DV. And then the decision variables, now we don't know their values. When you are starting, if you like check the equation here, when you are starting, you don't know the value of x1. You don't know. You don't know the value of x1. You don't know the value of x2. So right now, we are going to initialize their values to 0. 0 is when you don't know. Okay. So now we are going to give the value of the decision variable for Yogo to be 0. The decision variable for Choco to be 0. Okay. That's what you're going to do. And then there's something we are going to put here under the profit, because that is a profit function. Look at the profit function. Look at the profit function here. Look at the profit function. Don't worry, I will later post the link when we're about to end everything. Now, if you look at the profit function, the entire Z value is the whole of what? If you check it carefully, the entire Z value is the whole of this, the whole of 40x1 plus 50x2. So you're going to put, it's a formula. So you're going to put that formula inside this Z section where the cursor is. Okay. So I'm going to put 40x1 plus 50, but it's a formula. So I need to pick the 40 from here, pick the 50 from here. The x1 and the x2, we don't know the values. That's why their values are 0, 0 here. So now I'm going to write this formula there, equal to. You have to make it equal to. Okay. And remember, it's 40x1. So I'll pick this 40, then times. Look for times. Times is the star. So you do shift and then depending on your keyboard. So times what? Times x1. And the x1, we don't know the value, so it is what? 0. Now, the moment you press 0, you have to press Fn, or sometimes F4 key. And once you do that, watch it, watch the B, watch the B3. A dollar comes in front and behind the B. A dollar symbol comes in front and behind the B. I'll tell you why I have to do it. And the dollar sign is for the decision variables. Okay. And we do that dollar sign anytime we collect the 0, the decision variables. Okay. Now, the formula again says plus 50x1. So you now go and collect the 50, then you do times, then you collect the 0. The moment you collect the 0, you do the Fn, F4. And the dollars again comes in front of them. Once you are done, click enter. And the answer will be 0. As at now, it will be 0. We use a different color, 0, red. Now, the reason why it is 0 now is that we don't know the values of the decision variables. So right now, it is 0 until we get to know. Fantastic. So now let's move on to the next thing. The next thing we are going to do, okay, a hand is up. Okay. A hand is up. If you can type your question, to be honest with you. Okay. If it's not too much of a question, that will be the best. I will now be able to handle it. Unless it's a serious thing, okay, you can just say it's serious, and then I will just let you do that. Other than that, please, or unless it's long, you can say it's long. The next thing you want to do, okay, the next thing you want to do is, somebody says, I got lost along the way. Don't worry, okay. I told you that I will explain why the dollar sign came about. Don't worry. I'm going to explain that. Okay. I'm going to explain how the dollar sign came about. Okay. But all the same, let me just go over this. So I'll tell you why we have to bring the dollar sign. But if you like, I can tell you a bit of it now. The reason why I'm bringing the dollar sign is that you can see that the dollar sign, I am bringing it after selecting the decision variables. After selecting the decision variables. Okay. After selecting the decision variables. Now go to the formula and watch and see. Okay. You can see that the 40 is multiplying the decision variables. The 1 is multiplying the decision variable. The 4 is multiplying the decision variable. And when you go to the x2, the 50 is multiplying that decision variable. 2 is multiplying the decision variable. 3 is multiplying the decision variable. So it means that there are so many things that are going to be multiplying the decision variables. And we can't be doing all of them. If there were 100 of them, we can't be writing all of them all the time. So we bring the dollar symbol so that automatically, when we go to the other ones, we don't have to type the formula again. That's all. So the dollar symbol will indicate that we don't have to type the formula again. And when we get there, I'll show you what shows that we don't have to type the formula again. Okay, so you do this 40 times x1, which is a 0, and then 50 times x2, which you collect. So you do plus 50 times shift and then star for the times, and then you collect the x2, which is the 0. And once you do that, you do the Fn, F4 again. Then you click enter. Okay. And the symbol there will be 0. It's a formula, and it will change. Okay, it's a formula. These zeros, they will also change. The zeros will change as we go on. You see that the zeros will change because they are decision variables and they have to change. All right. The next thing is to write your constraints. So this section there, you write your constraints. Okay. So you write constraints. It's just a way of giving it a title. And in the constraint, let me see whether there's a question again. In the constraint, somebody says the sound is on and off. Okay. Let me turn off the video and see. Okay. So you write a constraint, okay, and then the constraint, we always have the left-hand side and the right-hand side. Now, the left-hand side, we used to call it usage, in case you remember. Then we have something we call sign, if you can remember. And then we have something called available. The available is the right-hand side, and the usage is the left-hand side. Now, watch where I put the usage. Very important. And then, of course, the first constraint was the labor constraint. So I can just write labor here. The second one was a milk constraint. So just write. And go back to the equation. Go back to the equation. And in the equation, watch. For the labor constraint, the first number is 1. The second number is 2. For the labor constraint, the first number is 1. The second number is 2. And then for the milk constraint, the first number is 4. The second number is 3. You are going to put these numbers inside the Excel. So for the labor constraint, you have 1 and then 2. And then for the milk constraint, you have 4 and then 3. So write it there nicely. Excellent. Now, so you just write the numbers, okay, that are in front of the decision. Now you go to the sign. If you can remember, the signs are all less than or equal to. So in Excel, just look for the symbol for less than and add the equal to. Okay. Look for the symbol for less than, and then it's just for cosmetic purposes. And then on the right-hand side is available. If you can remember, you can always let this equation be guiding you. The right-hand side, you have 40 for the labor, 120 for the milk. So you go and do the same thing. So on the right-hand side, you write 40 for the labor, 120. Okay. The only thing we are left with is the usage, this column. If you don't get anything, just raise your hand and let me know. Somebody says he wants to know the Z formula very well. Okay. Now, you don't need to bother much to know the Z formula very well because I've gone through that twice. But I'll just double click for you to see. Okay. You just have to take the 40, multiply by the 0, take the 50, multiply by the 0. Okay. And anytime you multiply by the zeros, which is the decision variables, you press the F and F4 key. And that's it. All right. Now, that dollar sign we put here, we are going to now make use of it in the usage here. So I'm just going to copy this formula. Watch it. I'm going to copy the Z formula, Control C to copy, come under the labor usage and do Control V to paste. Once you do Control V to paste, watch what happens. I'm going to do the same thing for the milk. Copy the Z formula, drop it in the milk usage, Control V to paste. And guess what happens when you double click? Watch it. When you double click, you can see that it is automatically picking the 1 and multiplying it by the decision variables. And picking the 2 and multiplying it by the decision variables. So the dollar symbol is now making it possible for it to automatically multiply it by the decision variable. Because when you look at the formula carefully, watch the formula. When you look at the formula very carefully, you will see that the 1 is also multiplying the decision variable. The 2 is also multiplying the decision variable. The 4 is multiplying the same decision variables that the 40 and the 50 were multiplying. So when you come to the X and you give that dollar symbol, it will automatically be multiplied. Now watch. Ladies and gentlemen, everything that you see as 0 here is going to change if we run the model. So this is a formulation of the model in Excel. Let's go and run it. Let's go and run it. You're going to run the model. Okay. So let me see by hands, those of you who have been able to formulate it like I've done. As long as I get 5 people, it means that some are following. Okay. It's not everybody who will be able to do it fast. But let me see by hands, those of you who have been able to, do, oh, we've got more than 5, man. Come on, guys, you are incredibly wonderful. We've got more than 10. Man, this is good. Justice, Kwesi, Manuela, Destin, Kwame, Amma, Jonathan, Constant, Erica, Edmond, Mohammed, Elizabeth, Mariam, Stephanie. Come on, these guys, you are incredibly ecstatic. Wonderful, wonderful. Now you can lower your hands and let's go and run the model. Remember, the decision variable is going to change. And once they change, the profit is going to change. And then the usage are going to change. So let's run the model. How do you run the model? Now, the first thing is this. In order to run the model, you need to go and click the data tab at the top. Click the data tab, data tab, data tab. Then on the far right, you see solver, solver with a question mark and an arrow. You see solver with a question mark and an arrow. If you don't see it, don't worry. I'm going to show you how you can show it. If you don't see it, don't worry. But then if you see solver, it means that you have been making good use of your Excel. It means you have been using your Excel very well. Okay. So if you don't see it, follow me. If you don't see the solver, this is what you should do. And be moving with me fast. Some of you are going to be behind. Click on File. Click on File at the top left. Click on File. Click on File. Then at the bottom, choose Options or Excel Options. At the bottom, choose Options or Excel Options. I know you've done that, okay? Now, a pop-up will come. The Excel parameter dialog box will pop up very soon. Okay. So you choose that, okay? You choose that. And then once you select that, you now look through the list, you see add-ins. Last but one on the far left pane, you see add-ins, add-ins, add-ins. Fantastic. When you look at add-ins, in the list, you see solver add-in. It will be somewhere under the inactive applications. You see solver add-in. And because I have mine already, mine is at the active application. Don't worry. Click on it like I have done. Click on it like I have done. And then come down to the bottom, you see Go. Under Manage, you see Go. You see Go. Click on Go. Click on Go. A pop-up will come. A pop-up will come. In the pop-up, you see solver adding. Solver adding. Solver adding. Okay. You see that solver adding pop-up. In the pop-up, you see solver adding. Now, there's a little box. There's a little box on the left of the solver adding. Tick it. You see that mine is ticked. Okay. Tick it. Tick it. Tick. 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 Okay. And then click OK. Tick and then click OK. Pack. And once you do that, you now see the solver adding on the far right. Once you do that, you see solver adding on the far right. Let me see by hand those who did it and have got it. You did it and you got it now. Not that you had it before, but you went through the process with me and you got it now. Fantastic, more than 10 people. So that shows that majority of you have gone through the thing. Now that you have solver adding, click on solver adding. Thank you, lower your hands. Now that you have solver addings, click on solver addings. Sorry, click on solver on the far right. Click on solver. Once you click on solver, a pop-up will come. Now, these steps I'm now going to go through with you are a little bit complex, so just work with me. Okay. Just work with me. Just work with me. Okay. Just work with me. Work with me. Click on solver, and then a solver parameter dialog box will pop up. Okay. I'm not going to be able to go through the process I went through now again, otherwise it would delay most of us. I told you that this is not the most important thing. Now, in the solver parameter dialog box, there's something we call set objective. Click there and delete everything. Click there and delete everything. If nothing is there, then wait for me to show you what to do. You see the cursor is blinking in there. The cursor will be blinking in there. Set objective. Now that set objective is our Z value. It's our Z value. So you see where the 0 for the Z value formula is. You're going to click it once so that it is collected in the set objective. Click it once. If you are following me and you are going by my approach, you should see in that box $D, $2, or simply D2. You should be able to collect D2 in the set objective. So the set objectives is our Z value. We are going to now find the actual value. Then you know that we are doing maximization. So the next thing below the set objective is maximize or minimize. We are using maximize. So you select maximize. Now maximize is the default, so that has already been selected. Okay. Maximize is the default, so that has already been selected. Okay. Now, so click on maximize. Now, you have to be careful that you don't go and be clicking places. Otherwise, the formula in the set objective can change. So remember that it's supposed to be D2, even as you move forward. All right, the next thing to do is to click the by changing cells. By changing cells, it's just directly below the maximize. By changing cell, what is that? It's simply the decision variables. You see, Excel has some funny ways of calling these things. And one of the funny ways is by changing cells. You know that value of 0 will change, so they call it by changing cells. Okay. When you say go over, I've missed a step, it doesn't really, I don't get it, because go over can mean a lot of things. Go over can mean go over everything again. And we don't have that time leeway to go through everything again. So sometimes you get lost. I told you that you get lost at some point in time. Okay, don't worry. You will have to get lost at some point in time. And then you will later have to watch the video. Okay, so under the set objective, I'll slightly go over this. Under the set objective, okay, you select the Z value, the 0, and put it there. Then you take max, maximum, max, maximize. Then you select the space for the by changing cells. Now that space by changing cell is refers to the decision variable, those green zeros. So you're going to highlight and collect those values into the by changing cell. So once the cursor is blinking in the by changing cell, click on the decision variable 0 and drag it to the next one on the right, 0, just as I've done. Click and drag it, and then release your hand. You will see that they will be collected. So you click inside where they have collected, they'll be collected there, and you see B3 colon C3. Okay, that is an indication that it's been collected. Now, these by changing cells are the decision variables that will change. That will change. Okay, so now we are going to do the most important one. We are done. Now you click the space, which is under the subject to constraint. The space under the subject to constraint. That's where you're going to put all your constraint there. All your constraint. And there's a kind of a diamond glass when you click the space. Okay, there's a kind of a diamond, round, kind of symbols. Now, to do the first constraint, you can add the constraint. Add one by one. Add by clicking add. So let me click add. You to click add, click add, click add. Okay. Once you click the add, a pop-up will show. The constraint parameter dialog box is going to show. Okay. This is it. It will show. This is a constraint parameter dialog box. Now, how do you deal with that? Now, you watch it carefully, and you see that there's a left-hand side called cell reference, and there's a right-hand side called constraint. Our left-hand side is called usage. Our right-hand side is called available. It's the same thing. So whatever value under usage will go to the cell reference. And whatever value under constraint will go to the available. So the cursor should be blinking in the cell reference. Now, watch carefully our signs. Our signs are all less than or equal to. And look in the middle there, the signs are less than or equal to. Because the signs, both constraints have the sign of less than or equal to, you don't need to change the sign. Other than that, you click this arrow near the less than or equal to. It will also give you equal to, greater or equal to, integer, binary difference. All of these, okay, are possible. In fact, later on, we will learn how to do the integer and the binary. So we'll come back to the integer and the binary. But for now, the two constraints we have are all less than or equal to. So we leave it like that. It's a default. Click on the cell reference now. And then we collect the information under usage into the cell reference. Collect and drag. So click on the first one and drag it to the second one. Click on the first one, hold and drag. Hold and drag. Don't release your hand. Hold and drag. Now, once you collected the two usages, release your hand. And you see that you have D5 colon D6 in the cell reference. Once you are done with that, click on the right-hand side, which is a constraint. The right-hand side, which is a constraint. That one too has got, in our Excel, we have it as available. And the values are 40 and 20. Okay, so you now collect the 40 and the 20. You collect them there into the right-hand side constraint. So I'll go and drag, pick the 40, drag it to 120, and then release my hand. Once you are done, if there were some greater than, you would have dealt with them and then separately. You would have clicked another add here, and you would have done that. If there were some greater than or equal to other things, you would have done it. But since we are done with all the constraints, you click OK. And once you click OK, the constraints are shown here in the subject to the constraint. We are done. The next kind of constraint we didn't showcase is the non-negativity constraint. How do you show that? Well, Excel has made it that automatic. You see, down this constraint, there's something called make unconstrained variables non-negative. Make unconstrained variables non-negative. So if it is not tick, you tick it. You tick it. That will show that you want everything to be non-negative. That is just to ensure the non-negativity constraint. Then at the bottom, just below that, you select the simplest method in the model formulation. The solving method we are using is the simplest method. So you select the simplest method and you are done. Ladies and gentlemen, listen carefully. At this stage, we are going to click, we are about to click solve. Once you click solve, I pray and hope that you went along with me and you will get the same result that I get. So click solve. The pop-up will tell you clearly that solver found the solution. Hooray! All constraints and optimality conditions are satisfied. Okay. So you will keep the result. But we are interested in one particular result called sensitivity. So on the right, under the report, select sensitivity result. Select the sensitivity result. Once you select that, at the bottom of your sheet, check down there, you will see that your sheet is called sheet 1. I'm about to click OK. Once I click OK, a new sheet will show up called sensitivity report 1. So once you have the sensitivity highlighted, click OK, and you have sensitivity report 1. There you go. Let me click on the sensitivity report 1 at the bottom here. And that's your answer. That's your answer. Now, the answer here, which is the sensitivity report 1, is what we are going to discuss. This is where you normally get about several questions being asked on this. Okay. Normally, sometimes under the exam conditions, I will only give you the sensitivity report and I'll ask you some questions. Okay. But for now, let me see by hands those who are able to do it alongside with me to get a sensitivity report. If you got it, raise your hand. Those of you who were able to get a sensitivity report 1, let me see by hands those who had it. If you didn't get it, lower your hand. If you got it, raise your hand. If you didn't get it, lower your hand. I got 3, 12 people got it. 12 people. Okay? That is way more than my expectations. Okay? I don't expect everybody to get it immediately, but the fact that some of you got it is fine. If you miss some of them, it's fine. Okay? If you miss some steps, it's fine. It's fine. Okay? I told you that we are all not fast enough. So you take your time, you later watch it again, and then you can go through it again. That's the beauty of learning. The beauty of learning is that everybody wants it quickly, but sometimes you can't get it quickly. All right. So this is a sensitivity report. Please, when you check the slides, you see that everything I went through is there. Okay? Everything that we've done is inside the slides, and you can go and check it all again. Okay? You can check it, and you will be able to get everything. I've cut and so all of these are in the slides, so you can check the slides and you can step by step go through it. Okay. Just go and check. Some of you will have infeasibility. It means that some of your values are wrong. It means that some of you didn't do the non-negativity constraint. Go and check the values. Some of you, when you were collecting the cell reference, okay, constraint, you didn't collect the constraint properly. There is surely a problem somewhere. Maybe you didn't type the right thing. Maybe you didn't copy the formula and paste it like I did copy the formula and paste. Okay, so go and check your formula that you have. Go and check your constraint that you have. Go and check what you put under the usage. Okay. All of these are signs that there's a mistake somewhere. The mistake can easily be corrected. So check it somewhere, and then you can sort it out. Go through the slides, and you can sort it out as well. So at this stage, I'm going to ask you some 13 questions based on this result. 13 different questions based on this sensitivity results. So at this stage, bring all your heart and your mind into this. Okay? Forget about whether you got it right or you got it wrong. It doesn't matter. At this stage, hold on everything and then bring your mind to this sensitivity result. Question number 1, you want to write it down. First question, I want you to answer it for me. From the sensitivity report, what is the optimal solution to this problem? From the sensitivity report, what is the optimal solution to this problem? The question, what is the optimal solution to this problem? The optimal solution. Just looking at the results here, which area, which column, or which area can give us that answer? Who can guess? Which area or which column can give us that answer? You either raise your hand or you type it there. Which area or which column can give us that answer? Which area or which column can give us that answer? Okay, the optimal solution. The optimal solution to the problem. Kwame. Let's see whether Kwame will be able to do something. What is the optimal solution? Yes.
The variable cells section.
Which specific column?
Final value.
Okay, thank you. So the optimal solution is always at the final value of the variable section. Now, this is where you have to write. This is where you have to put it down in pen and paper so that next time you don't miss it. So the optimal solution is always found at the final value of the variable cells. Now, the reason why you need to bring up the variable cells is because there is another final value at the constraint section. You realize that? There's another final value at the constraint. So we are interested in the final value of the variable cells. That is the optimal solution. Okay. So you pick the values and you tell it that the optimal solution to this problem is to produce 24 units of fine yogo and 8 units of fine chocolate. That's how you put it. 24 units of fine yogo and 8 units of fine chocolate. Remember, the Fan Yogo was the X1. And if you can remember, in our normal hand computation, this was the answer we had. The Excel is just for more than even 2 variables. And that's why we are using the Excel on our hand computation first. So please watch the word optimal solution. It always refers to the final value of the variable. It's so simple. Next question. What is the corresponding value of the objective function? Now, the word corresponding means that he wants you to use the final values here to get that next one. What is the corresponding value of the objective function? It's a matter of saying that what is the objective function value? Now, the objective function value is called what? It's called what in our exercise here? The objective function value, what is it? Okay. Is it a cost? Is it a revenue? What is that? Okay. It is a profit, exactly. It's a profit. So what is the corresponding value? Well, he's asking you, what is the overall Z value, the profit value? The profit value, what is that? What is overall profit value? How do you get that? Okay. How do you get that is more important to me than even giving me the answer. How do you get that? Who can tell me? Using the table, okay? Remember that at this stage, the only thing you have here is using the table. How would you compute that? That's a question. How would you compute that? Let me give it to Martina, Dr. Martina.
You would substitute your final values into your Zmax function. As your X1 will be 24 and your X2 will be 8.
So how would you compute it? Tell me the computation. What will be equal to what?
40 times the Zmax or the maximum profit will be 40 times.
Where did you get a 40?
The 40 is the objective coefficient.
So that's
for
what you
your
say first.
Okay.
Because we are assuming that at this stage you are using only the Excel. All right, so continue with your formulation. To be what times what?
So it will be 40 times 24 plus 50 times 8.
Perfect. Excellent. So that's how it's supposed to be, guys. Let me just repeat what she said. So she says that anytime you want the corresponding value of the objective function, the Z value, the point is multiply each final value with its corresponding objective function. That's the point. Multiply each final value with its objective function coefficient, objective coefficient. Multiply each by the other, and then add them together, and that will give you the overall Z value. That's it. Okay, so keep that in mind. Keep that in mind. It's just knowing where you pick what. Okay, you pick the values based on where you see them. All right. So that is the next question. Any question on that? So this is what she said, 24 times 40 plus 8 times, that'll give you 1,360. You understanding this is important because when we get more variables, X1, X2, X3, X4, X5, X6, then you know how these things are done. Next question. What is a reduced cost? Now, let's go to the Excel and then look at it. Do you realize that each final value has a reduced cost value? The same way each final value has an objective coefficient. So what is that reduced cost value? What is it? Well, in this case, the reduced cost values are 0 and 0. But what is a reduced? Ladies and gentlemen, reduced cost value is, and you have to understand how it is first before you can appreciate it. In short, it can be positive, it can be negative, it can be 0. When it is 0, it's very important. When it is positive or negative, then it's a bit of a problem. Why? In fact, what is it actually? The reduced cost, and you might want to put this down, the reduced cost value is the opportunity cost of producing that decision variable. The reduced cost value, the RC, is the opportunity cost of producing the DV. Is opportunity cost of producing that particular decision variable. Now, let me tell you why. What is an opportunity cost? Well, in economics, opportunity cost is the next best alternative for gone. Right now that you are listening to me, you are spending some time and resources to be able to listen to me because this thing is important to you. So more or less, you are producing some knowledge to yourself. But there's a cost of doing that. The opportunity cost of you listening to me right now would have been sitting somewhere at a wedding, attending a funeral, attending some naming ceremony, okay, being in the beach somewhere, going out with the children, okay, having a rollicking time on a date, something. That time has been sacrificed, and you're using that time for this. In that case, what are you telling me about that one? You are telling me that that time is not as important as this, isn't it? It means that that time is not as important as you be. It means right now you are saying that being with me and listening to me is more important than that one. So you are not going to produce that one, but you're going to produce you being with me. You see, the final value is 24 for Fanyogo, and its opportunity cost is 0. What does that mean? Anytime a final value's opportunity cost is 0, it means that that final value has to be produced. I want to repeat that. If a final value's opportunity cost is 0, or its reduced cost is 0, what you are trying to say is that the cost associated with the production of that final value is 0. In other words, there is no damaging effect you are going to incur if you should produce this Fanyogo of 24, because you are not going, the time and the resources and anything, okay, you couldn't have used to produce anything better. And so the sacrifices you have made are not that much significant. In fact, there are 0 sacrifices you've made. And so you can go ahead and produce the 24. The same way fan choco here means that 8 means that there's opportunity cost of producing fan choco of 8 is 0, which means that you can go ahead and produce the fan choco. Now, why am I using the word you can go ahead and produce? Because if the value here was not 0, in a maximization, it would be like minus something, minus 10, minus 20, minus 15, minus 3. When you have a value for this, do you know what that means? It means that if the value appears and is not 0, it means you don't have to produce the final value. And so you will notice that Excel will tell you that the final value should be 0. So here is what you should put down. If the reduced cost has a value, whether it's a negative value or it's a positive value, if the reduced cost has a value, then its final value will be 0. Its final value will be 0. What does that mean if its final value is 0? Well, what it means is that its opportunity cost is costly. And so you should not produce the final value. That's why it is 0. Let me give you a typical example. And let's be practical here. Okay, let's go to our equation. What is the profit you are likely to gain from fan choco? Per unit profit for fan choco is 50. What if it was 90? What if I have priced the profit per unit for fan choco to be 90? Whoa, that's a lot. That's a lot. That means that you need to, it's going to affect and destabilize. Okay. You want to make that kind of per unit profit? Well, let's put that into the Excel and see. Okay. So let's go to our Excel. Okay. This is our Excel. Let's go to our sheets. Okay. And I'm just going to do back trace. Oops. Let's go to our Excel here. And I'm going to change this value of Choco from 50 to 90. Watch what happens. It's going to make it impossible for us to produce yogo. Watch it. I'm going to change this value of 50 to 90. Enter. Now, and I'm going to run the whole thing again. So I'll click on solver again. And I'm going to click solve. And I'm just going to generate another sensitivity report. So look at the bottom of the Excel sheet. And then you see another sensitivity report. And I'm going to show this. It's going to be sensitivity report 2. Watch it. That's it. That's sensitivity report 2. Let me show you. This is a sensitivity report 2. The price of Choco was 90. Now see what it has happened. What is happening is that the entire linear programming solution has changed. Now the final value for fine yogo is 0, which means we shouldn't produce any fine yogo. We should put all our attention in the production of 20 sachets of fine choco. Question. What if you decide to force yourself and produce the fine yogo? Well, it says here that you're going to incur an opportunity cost of 5. Now, the minus here means you're going to lose. The minus is simply an indication of a loss. So you're going to incur an opportunity cost of what? Of a reduced cost of 5, which means that now that we are not supposed to produce fine yogo, if you force to produce fine yogo, say, as it stands now, if you force to produce fine yogo, what will happen? You will incur this cost. That's what it means. Now, so what will make me want to produce fine choco? Sorry, fine yogo. Well, right now, as it stands, you can't produce it because you will incur opportunity cost of 5. You incur a reduced cost of 5. So what will make me want to produce it unless you increase its objective coefficient? Unless you increase its per unit profit. What will make me produce this thing? Well, if the value is high, if the profit is high, so the profit of 40 is not enough for me to produce it. So don't produce. So as it stands now, don't produce. This is because of the way the linear programming was formed, which I just did. So what is the reduced cost? The reduced cost value, okay, is telling you the opportunity cost of going ahead to produce something that is not producible, or is telling you the sacrifice you have already made, okay, for undertaking the production of a particular decision variable. And all of these things, ladies and gentlemen, are inside your slide. So let me just go back to this slide and then share with you. Everything I've said is here. So the opportunity cost, okay, how much of the objective coefficient we take. And I'm giving you an example that if the final value of X is 0, the reduced cost value that we have tells us how much the objective function will change if we force X1 to be non-zero. It simply means that if we force to produce X1. Now you can see that S1, fine yogo, was not supposed to be produced. Okay. Now the reduced cost will tell you, okay, if you force to produce, if you are forcing to produce it, it means that you are forcing it to move from 0 to a positive value. If you do that, the reduced cost will tell you the punishment you are going to get. So now let's go back to the point that for maximization problem, the reduced cost will be non-negative. See, non-negative here means that they are positive or 0. That's what we have in our case. So you can see that in our case, maximization, I gave you a situation where the reduced cost is 0, and I've given you one where it is negative. Okay. Now, it must be non-negative, and you will see that later on. Okay, and then for minimization, it must be non-positive. Okay, indicating that a rise in the variable will lead. I'll explain this when we come back to allowable increase and decrease. So let's go back to our question. Why does the reduced cost column contain zeros? Who can tell me this? Because I've explained it already. Why does the reduced cost column contain zeros? Okay, if you look here, why do they contain zeros? Who can tell me? Why does the reduced cost column contain zeros? The answer is what? Why does it contain zeros? Okay, let me see whether Edmond can just give us the situation. Edmond.
Okay. Yes, sir. So please, the reduced cost is zero because there was no opportunity cost. They made use of the available resources.
Come again.
Hello, sir. The reduced cost is zero because there was no opportunity cost, and they made use of the available labor hours and the milk available and the labor hours available. They made use of all. There was no opportunity cost.
Thank you. Well, to be honest with you, it has nothing to do with the available resources or anything here. Your first point is what I want taking, okay? That there was no opportunity cost. But why does it contain zeros? Contains zeros because what? Because we produced the fine you go and find chocolate. Because they are producible. Because we are producing them. Okay? Because we are producing them at no opportunity cost. Because they are producible. Because if they weren't producible, if there was zero, we wouldn't have had a zero reduced cost. So the fact that they are zero means that we have because the optimal values are positive because they are producible. Because they are producible. Yeah, that's it. That's it. Now let's go to the next question. Which constraints are binding? Which constraints are binding? Now, let me just remind you that at the bottom section here, we have the constraints. I'll come and talk about these two. But at the bottom section, we have the constraint. By the way, the final value of the constraint is the left-hand side of that constraint. The one we normally call the usage. Okay, the final value is the left-hand side of the constraint, the one we call the usage. Then the right-hand side of the constraint is actually the right-hand side of the constraint. Now, looking at these two constraints, labor constraint and milk constraint, which constraints are binding? We've already done this before. You can tell me. Which constraints are binding? You can type your answer, you can raise your hand. Which constraints are binding? And I've already indicated to you that the left-hand side of the constraint is the final value. The right-hand side of the constraint is the constraint RHS. Which constraints are binding? Okay, Amma says labor is binding. Okay, well, to be honest, all the constraints are binding, isn't it? Because the constraints are said to be binding. Note it. The constraints are said to be binding when the left-hand side equals the right-hand side. Now for labor, the left-hand side is 40, the right-hand side is also 40. For milk, the left-hand side is 120, the right-hand side is also 120. So which of those constraints are binding? All of them are binding. A binding constraint is where there are no slacks. Write it down. A binding constraint is where the final value equals to the right-hand side, or where the left-hand side equals the right-hand side. A final constraint is where there are no slacks, zero slacks. Because when there are no slacks, then the left-hand side is equal to the right-hand side. Okay, so that is it. And of course, we also say that the binding constraint is where the usage is equal to the available. Where the usage is equal to the available. But there's something about the shadow price I'll come to very soon. All right, so let's go to the question. Now I want you to look at the shadow price. The shadow price. What is it? Well, look at it carefully. Between the left-hand side constraint and the right-hand side of the constraint is something we call the shadow price. The shadow price. It's probably one of the important concepts you got to learn in this topic. What is it? Now, the two confusing concepts are the reduced cost and the shadow price. And I'm sure you remember that we said the reduced cost is the opportunity cost of producing a particular value. Okay, so what is the shadow price? Well, look at the word shadow. When you are in your shadow, it's like you are kind of mimicking you. It's moving as you are moving. And it's a price. A price means it's a value. Something that has a price is value. So the shadow price is also called the dual value. The dual value. The dual value. What is that? Well, the dual value or the shadow price is the per unit change in the decision variables or in the objective function when there is a 1 unit change in the right. I want you to repeat this because it sometimes can be a little bit confusing. So don't worry, I'll repeat this. It is a marginal change or the marginal value of 1 extra unit of resource. When I say it like this and you don't take your time, you might not understand because it sounds very economic. It's a marginal value of an extra unit of a resource. But let me make it very simple. Simple language, okay? Simple managerial language. What does it mean? Well, the shadow price tells you that by how much the objective function value will change if there is a 1 unit change in the right-hand side of the constraint. I'm going to use the equations that we have here for you. Now watch it. This is the labor constraint, and then this is the milk constraint. As it stands now, if I should look at the labor constraint, it's 40 hours now. If I should increase that 40 hours, let's say somebody is doing overtime, and there's an increase in the 40 hours by, say, 1 unit. I can say 1 hour, but let's say 1 unit. When you use the word unit, you don't worry yourself about the unit of measurement. So I increase the labor by 1 unit. What is going to happen to the objective function value? What will happen? Well, whatever will happen is measured by the shadow price. Oh yeah. So the shadow price will tell you by how much the Z value will change. You see the word I'm using, change. I'm using change because change can be increase or decrease. So by how much the objective function value will change if the right-hand side of the constraint, any of them, changes. I use change. But suppose I say that if the right-hand side of the constraint increases by 1 unit, how much would the Z value increase? I'm using increase. The same way, if the right-hand side of the constraint decreases, okay, if it falls, by how much would the Z value also fall? This by how much is the shadow price. So you multiply that original increase in the right-hand side here, that increase or decrease, multiply it by the shadow price, and that will tell you by how much the Z value is changing. Let's take an example. Now, I want you to look at the shadow price now. The shadow price. Okay. Where is the shadow price? You look at the shadow price now. And when you look at the shadow price, and look at the shadow price for labor, it's what? 16. And the shadow price for capital. Okay. The shadow price for labor here is 16, and the shadow price for gallons of milk. So what does the 16 mean? The 16 here for labor means that if we are to increase hours of labor by 1 hour, now I'm using the actual terminologies. If we should increase hours of labor by 1 hour, which means from 40 to 41, that's what I mean by 1 hour. Oh, and by the way, you want to take note of the by and then the from. So if you increase labor hours by 1 hour, which is from 40 to 41, how much is that going to increase the profit margin? It will increase the profit margin by what? $16 or 16 cedis. That's what it means. That's what a 16 labor shadow price means. So let me ask you guys, if you are to increase the gallons of milk, listen carefully, if you are to increase the gallons of milk by 6 gallons, if you are to increase the gallons of milk by 6 gallons, by how much is profit going to increase? Who can raise a hand and tell? If you are to increase gallons of milk by 6 gallons, by how much is profit going to increase? Derek Abuaje, by how much is profit going to increase? Yes, Derek, we can't hear you.
Doc,
Go ahead.
720, 720.
Okay. Derek, I can tell you that that is wrong. If you are to increase gallons of milk by 6, by how much is the profit going to increase? You see, I've used the word increase to even guide you. Faustina, Papo. Faustina.
Dog, 120.
By how much is profit going to increase?
120.
Okay, that is also not correct. I like it when people get it wrong because what it means is that, you know, some don't yet understand it. But the answer is being written, so I'm going to just wait. The answer is 36. The answer is 36. You have increased the gallons of milk by 6. So it has moved from 120 to 126. I'm not interested in the, is the buy. So you've increased it by 6. So by how much is profit going to increase? You multiply the 6 by the shadow price. Remember, you multiply the change by the shadow price. And the change is 6. And the shadow price here is also 6. So you multiply 6 by 6, that's 36. If you have been following me, you will know that it will change by 6. Let me take another example, because I like it. Example is more efficacious than precept. Now, let's assume that we reduce hours of labor. Now, don't rush, think. We reduce hours of labor by 2 hours. We reduce hours of labor by 2 hours. What will happen to profit? And you see, I didn't complete the sentence, so you have to complete it. What will happen to profit? Who can tell me? We reduce hours of labor by 2 hours. What will happen to profit? What will happen to profit? We reduce hours of labor by 2 hours. What will happen to profit? Edmond.
Profit will reduce by 32 cedis.
Exactly. Perfect answer. Profit will reduce. I like the word you use, reduce, because we were reducing that. So if you reduce this 40 by 2 hours, you multiply the 2 by the shadow price of 16, so you get what? 32. So it means that profit will also reduce by 32. That is what we mean by the shadow price. So the shadow price tells you by how much the profit is going to change if there should be a change in the right-hand side of the constraint or the resource constraint. So there are some questions, okay, that sometimes you have to appreciate it here. Now, what's a very tricky question in all of this, in these very examples I've been giving you? I have 2 questions. One of them is this. If management could obtain extra resources, which one would be of most value to them and why? If management were to get another kind of resource, which one of the resources that you see here will be of most value to them and why? Which one will be of most value to them and why? Augustine. Which one will be of most
Hello, Doc. I
Yeah.
think labor will be of most value to them because the shadow price of labor is higher.
Perfect. Labor will be of most value because it's the one with the higher shadow price. The word is higher because you are doing a comparative analysis. So you use the shadow price to think. Now let's go to the next one. Okay. But always you have to ask yourself higher by how much? Okay, higher by how much? Now let me trick you with another one. What if management could increase profit by either increasing labor by 20 hours? Okay, now listen carefully. You are increasing labor by 20 hours, but gallons of milk by 40. You are increasing labor hours by 20. You are increasing gallons of milk by 40. Which should they choose and why? Which should they choose and why? Okay, have this table in front of you. Which should they choose and why? Those of you who have increased your hand, I'm lowering your hands so that you can increase them again so that I know that you did it by yourself. Okay, which one would they choose and why? Which one would they?
I'll still go with the labor because if you look at the shadow price of labor 16, if you increase it by 20 hours, that will give you an increase in profit of 320. But if you increase the gallons of milk, which are the shadow price by 6 by 40 hours, that will be 240 in profit. So the labor is still better.
Smart, very smart. These are the people you want to befriend. Okay, the people you should associate your life with. You are the average of the 5 people you move along with. So even though you have increased gallons of milk by 40, the shadow price is very small. If you multiply that 40 by that, you're still not going to get enough than if you should multiply the 20 increment in the hours. If you multiply you see hours was increased by 20. So you multiply the 20 by 16, you get 320. So that 320, it means that profit increases by more. So at the end of the day, you are not looking at the increase, but you are looking at the one that increases profit by more. And that's the most important thing. Always focus on the one that increases profit by more. And this will help you significantly in analyzing. This is called sensitivity analysis. This is the meaty part of the whole exercise, okay? Anyway, the answers are all here. Now let me trick you again. All right, I'll trick you again. But for now, let's see. Somebody says, how did Excel determine the shadow price? Oh, come on. There's so many things that are happening. By the way, the shadow price is called the dual value. You can best understand the shadow price by using what is known as the dual formulation. In the linear programming that we have formulated is known as a primal. And according to the complementarity approach, the complementary slackness approach, every linear programming model has a primal and a dual. If you formulate this thing in the dual fashion, you will see that the 16 and the 6, okay, are the actual final values of the dual formulation. They are the true values. So how is Excel doing that? You have to use a simplex method because the simplest method will guide you into finding this. Okay, and I have done the video on the simplest method. Okay, I didn't want to bother you guys much, but the MPhil guys, I bothered them. So I will urge you to go and check the simplex method. Okay, video. It will explain all of this. Okay, because if I start here, somebody will cry. All right. So let's go to the last thing we are supposed to talk about for this on the screen. It's known as the sensitivity range. Look at the screen and you see that there's something known as the sensitivity, allowable increase and allowable decrease. We have spoken about everything actually. We have spoken about all of the things that you see here, except the ones on the far right, which is known as the sensitivity range. The sensitivity range. Allowable increase, allowable decrease is very important. It's very important. It's so important. Okay, so let me explain. First of all, determine the sensitivity range for the objective function coefficient, and then determine the sensitivity range for the constraint. Now, I want you to look at this. The objective function coefficient, that's what you have here, 40 and 50. The allowable increase and the allowable decrease are for them. They are for them. But what do they mean? I'm going to do one, explain it, and then you will do the others. Okay. So it's a computation that you're going to work with me on. So let me just rewrite them here. So when you look at the sensitivity range, okay, we use the word sensitivity range like this. And it's normally telling you some values that are between some ranges. Now, in the Excel, you will notice that there's an allowable increase. Let me show you first. And then there's an allowable decrease. The allowable decrease is subtracted from the coefficient. And the allowable increase is added to the coefficient so that you get a range. Some of you remember confidence interval. That's the principle of confidence interval. So if I want to know the sensitivity range is telling us the upper limit and then the lower limit of that particular coefficient. So I'll take an example. So it's the sensitivity range for the objective coefficient. Okay, I just want to change this to make it objective coefficient. The sensitivity range for this objective coefficient is supposed to be the lower limit, we call it the lower bound, and then the upper limit or the upper bound. The sensitivity range is what I've just shown you here. So if I want to get a sensitivity range for the Fan-Yogo objective coefficient, the sensitivity for Fan-Yogo objective coefficient, Fan-Yogo, I'll just use this one to represent it. This is how you compute it. The lower bound is supposed to be the objective coefficient minus the allowable decrease. The objective coefficient minus allowable decrease, and then the right side will be that same objective coefficient plus the allowable increase. Okay, so let's get a sensitivity range for Fan-Yogo objective function. The objective function for Fan-Yogo was 40. So you write 40 here minus the allowable decrease. What is allowable decrease? Well, when you check the sensitivity range for Fan-Yogo, the allowable decrease is 15, all right? And the allowable increase is 26.7. 15 for the decrease, 26.7 for the increase. So what you are going to do now is that you do the 14 minus 15. Less than, sometimes you use less than or equal to depending on how you want it to be. Okay. And then the sensitivity range for the upper bound will be the 40 plus the 26.7. 40 minus 15 will give you 25. And then, fine, you go. The 40 plus 26 will be 66.7. So this thing that you are seeing down here is the sensitivity range or the sensitivity band for the Fan-Yogo coefficient. What does it mean? What does it mean? Well, before I tell you what it means, I want you to find the sensitivity range. And the way you can easily tell me is that you tell me the value. So if it was this 25, you tell me one is 25, the lower bound first, the other is 66.7, the upper bound. Okay? So I want you now to tell me the sensitivity range for the others. Okay? And I'm going to give you, so you tell me. So you have this. What is the sensitivity range for Fanchoco? Who can write me the answers for the sensitivity range for Fanchoco? And then you also should find the sensitivity range for labor and milk constraint. For labor and for milk constraint. Do all of that sensitivity range. Please be part of the doing, because that's the only way to help you to know that you are doing something. Okay. What is the sensitivity range then? Find the sensitivity ranges, and then I'm going to tell you what they mean. Who has been able to find all three? Raise your hand. If you've been able to find all three, raise your hand and let me see. All three. For Fanchoco, for the labor constraint, and for the milk constraint. Okay. So let me pick one of them. Christiana Anson. What is the sensitivity range? Yes.
Hello, sir.
Yes.
Please, the sensitivity range for choco is 30 and 80.
Good. Continue. The rest.
And then for labor, 30 and 82. And then for the last one is also 60 and 160.
All right. Okay. So that's it. That's it. You'll be able to crack it, and I know all of you will be able to crack it. That is how you find the sensitivity ranges. So we are going to take the first one that I did, and I will explain it with you. Okay. Where's the first one that I did? Okay. This is the first one that I did. The sensitivity range, and I did it for Fan Yogo. Now remember that that value which is changing is the 40. 40 was the price per unit for Fan Yogo. Okay, so that was 40. And the 40 is between 25 and 66.7. So what does that mean? What does that mean? Well, this is what it means. It means that as long as the price of Fan Yogo, as long as this price of Fan Yogo is varying, is hovering, is dancing between 25 and 66.7, cedis, as long as it's dancing in between, the optimal solution point, which was 24 and 8, won't change. As long as it's in between, the optimal solution point will not change, even though the Z value will change. So the sensitivity range of 25 means that, this value of 40, it is the price per unit. Do you remember that at some point we increased it for that of the 50, we moved it to 90, and it changed. The solution changed because it changed to 0 and then 20. Do you remember? Yes. Now, it changed. Now, the reason why it changed is because for that one, we exceeded a bound. Anytime you exceed the bound, the upper limit or the lower limit, the optimal solution of 24 and 8 will change. But as long as you are within the sensitivity range, the optimal solution will not change. So what this sensitivity range is telling us how close you can see, it's managerial beautifully. It's beautifully managerial because you can advise management that they can increase this price from 40 to what? To 50. Yeah, no problem. They will still be producing within. The optimal solution will not change. What it's going to do is that is going to help them get more profit. Remember, the Z value will change. The Z value will change. The Z value will change. But the optimal solution of 24 and 8 will not change. as long as you are dancing between 25 and 66 sensitivity range. So the sensitivity range help us to be able to know how we can vary our objective coefficient. But it also helps you to know that you don't have to increase the thing too much. Neither do you have to decrease it too much, because then you're going to change your situation. Okay. If there is time, if there is time, I'm going to demonstrate this in the Excel for you. Okay. If there is time, I'll demonstrate this for you. Okay. In fact, let me quickly demonstrate that for you, and then you will appreciate it even more. So I want you to look at the sheet that I have here. Okay. You don't have to change it. And our original values were 50 for this and then 40 for that. Okay. Those were the original values. Look at my screen. And what I'm going to do now is that the sensitivity range for Yogo was 25 to 66. So I'm going to increase this Yogo 40, not to 66.7, but I'm just going to move it to 60. And according to what we are saying, the Z values will not what? The optimal solution of 24 in our head and 8 in our head will not change. But then we expect that the Z value itself will change. So let's run it and see. So 24 and blah, blah will not change, but the Z value changes. That's our solution. Let me show you the sensitivity range for that. Look at sheet 3. This is the sensitivity range for that. Watch it. You can see that even though we increase the thing to what? To 60, which is here. 60 was still within the sensitivity range. You can see that the optimal solution hasn't changed, isn't it? That's the optimal solution. It's still not changed. It's still 24 and 8. And now look at its upper bound again. The upper bound is still what? 6.6, which means that if you should add that 6.6 to the 60, you will still get that upper bound we had originally, which was 66.7. We are still maintaining the upper bound. And look at the decrease. Look at it. Okay, 60 minus 35 will give you 25. So it means that the sensitivity range is still there. It has not changed at all. It hasn't changed. Why? Because we are within that. But now let me exceed it slightly. So I'm going to do the thing and exceed it slightly. Okay. Instead of 60, we are told not to go beyond 66.7. So I'm just going to go to 67. Is this 66? Okay, let me just go to 68. I'm going to change this thing to 68. Let's move it up slightly. Let's see what is going to happen to the sensitivity range. Let's run it again. Let's see whether the objective function will change. Sorry, the coefficient. Remember the objectives. Sorry, let's see whether the final value, the optimal solution will change. Let's see. So I just went above the sensitivity range slightly, the upper bound. The upper bound was 66. I'm now gone up slightly. Let's see what happens. Slightly. Remember, it's sensitive. So I'm going to run it again. The result. I mean, without even bothering yourself, look here on the left. Okay. Even without creating the sensitivity bound. Okay. Let me just show you the sensitivity range. This is a sensitivity range. Watch it. Straight away, the final value has changed. Watch it. Now we have a change in final value of 30 and 0 instead of what? Instead of 24 and 8. So the beauty of this is that it helps you to know that anytime you're within the sensitivity range, the optimal solution will not change. But if you go above the sensitivity range, the optimal solution will change. It will change. And that is exactly the result. Now, but even though the optimal solution will change, as for the Z value, it will continue. Even though once you don't exceed the sensitivity band, the optimal solution will not change. But in whatever case, as for the Z value is going to change. The Z value will by all means change. So that one, you are guaranteed of that. Okay. And in all cases, you can see that the Z value is changing. 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 Okay. Now, that is not the same thing when it comes to the constraint. So I'm going to take you back and then we change something of the constraint. Look at the constraint. This one was 40. And now look at the constraint. The constraint, if you should increase, one of you gave us the constraint values to be what? Type the constraint, the lower and the upper limit for the labor constraint for me. Who has it? The labor constraint and then the no constraint. Sorry, just the labor constraint. What was the lower level? What was the lower limit? Those of you who did it. It was 40 minus 10, which is 30, isn't it? So somebody has typed it in there. Then the upper is what? Good, 30 and 80. So 30 and 80, okay? I'm going to still keep them within that range. Watch it, 30 and 80. So it says that don't bring this 40 below 30 and don't take it above 50. Okay? But it doesn't apply to the constraint, and I want you to pay attention here. So I'm still going to maintain it within the range, 30 and 80. I'm going to make it 70. So the available, I'm going to make it 70 at the right. Okay, I've made it 70 at the right. What's happened? Well, we said that as long, in the case of the objective coefficient, in the case of these objective coefficient, the optimal solution will not change. Even as long as you're within, the optimal solution will not change. Well, look at the constraint. I'm going to run the constraint. You can see that the constraint is, it has, what we said has nothing to do with a constraint. The constraint, even if you are within the sensitivity range, look at it, it has changed. It has changed. Even though it was between 30, in fact, let me show you the sensitivity range. Okay. Even though it was between 30, watch it here. Even though it was between 30 and 80, right? And it's still there. Watch it. It's still 30 and 80. Okay. But the optimal solution has what? Has changed. Look at it, 6 and 32. So we only say that the optimal solution will not change only when it comes to the objective coefficient. That's when we are talking about, okay? It's only when we come to the objective coefficient. If the objective coefficients are within the sensitivity range, if these objective coefficients are within, then the optimal solution will remain the same. But it doesn't apply to the constraints. With the constraint, whether you are within or you are not within the sensitivity range, the optimal solution will still change. But what is so significant about the sensitivity range for the constraint? This is what is significant. I know. It's getting interestingly plenty. But this is what is significant. Watch. The sensitivity range for labor was 30 and then 80. What does that mean? It means that you can increase labor hours from 40 upward till you get to 80. But don't increase labor hours after 80. Now, why is that so? Why is it that don't increase labor hours after 80? Now, I want you to watch something, the one I just did. Watch it carefully. Watch it. Watch it. Now, the one I just did, where I increased labor hours to 70, it was not about this final value, because I told you that the final value will change. But look at the shadow price. The shadow price remained the same as long as the labor was within the sensitivity range. What if labor was not within the sensitivity? What if you exceeded the upper limit of 80 and it went beyond the 80? What if you exceed the upper limit of 80 and you went beyond the 80? Let's do that. So I'm going to change this value of 70 and move it above 80, say 83. Okay. So labor hours has gone up to 83. It has exceeded the sensitivity range for labor. What? Well, we already know that the decision variables will change. The optimal solution will change. But what will happen? Let's solve this. You create another sensitivity range for this. This is a sensitivity range for that. What happens to the shadow price? The shadow price will change. The shadow price changes. So as long as you are within, and listen carefully, ladies and gentlemen, this is critically important. As long as you are within the sensitivity range for the coefficient, this one, as long as you're within the sensitivity range for the coefficient, the optimal solution will not change. But when you exceed it or come below it, when you're out of the range, then the optimal solution will change. Okay, what about a constraint? As long as any constraint is within the sensitivity range, the shadow price will not change. But the moment you exceed the sensitivity range or you go above or below the sensitivity range for the constraint, then the shadow price will change. And so the sensitivity range is very good because what it's doing is it's always helping you to increase. In management, we always want to reduce something, increase something, reduce something, fire some workers, hire, fire, and things like that. But there's a limit to which you can do that. You can't reduce workers back below a certain level, which is a lower limit of the sensitivity band. Neither can you employ so many workers. And we see that in government institutions. When you employ so many workers, there's laziness, there's check-ins, and people are just not working. There's wastages that are going to be created in the process. And that is exactly what happened. And you can see that even here, there is wastage that has been created in the process. Okay? There are slacks that have been created by going beyond the sensitivity range in there. So the beauty of the sensitivity range is that it helps you to be able to know by how far you are going. See, you can, all of these things that we are doing, you can affect profit. You can affect the Z value, all right. But the question is that, how is it going to affect one, the optimal solution, the decision variables, and two, the shadow price. And one, somebody will say, oh, but what's the big deal if it affects the shadow price? Well, it's a big deal because remember, the shadow price will tell you by how much profit will change. So you have to know that the shadow price is not zero, because if the shadow price is zero, it means that even if you do anything to the right-hand side, profit will not be affected. Okay. Now let me ask you final questions. These are the concluding questions, and let me see your hand if you can answer them. Conclusion. As long as any change in the constraint is within the sensitivity limit, what happens? As long as any change in the constraint is within the sensitivity limit, what happens? What happens? This is important. What happens? Okay. As long as any change is within the sensitivity limit, what is going to happen? Okay, so Edmond Forsen.
Okay, the shadow price does not change.
Good. What else happens?
And the final value too remains the same.
Well, the final value will not remain the same. You've tried. The shadow price will not change. That's fine. Okay. But what else? Let's go to Amajem for. Okay. Amma, try it.
Hello, sir. The
Yes.
optimal solution will change.
The optimal solution will change. Good. He said the shadow price will not change. That's good. The optimal solution will change. What else? Something else will change. Can somebody type that for me? Because people are not cracking that one. Something else will change. What will change? What will change? It's simple. The Z value will change. In fact, in all of them, the Z value will change. So when I ask you what happens, I don't want you to tell me only what doesn't change, but tell me what changes as well. Okay. So the Z value will change. The optimal solution will change, but the shadow price will not change. Okay. Okay. Let me ask you some questions. Are there wastages in the Farm Milk Ghana Limited? Are there wastages? The general one that we did. Are there wastages? Yes or no? Are there wastages in the Farm Milk Ghana Limited, the original one that we did? Are there wastages? And the answer is what? Is no. Are there any milk leftovers? Are there any milk leftovers? Any milk leftovers? In the original one we did. Are there any milk leftovers? You see the way the questions are twisted and all of that. Okay. No milk leftover because there are no shortages. Okay. Which is the most critical resource for raising profit? Which was the most critical resource for raising profit? Labor. Kingsley, that's correct answer. Okay. It was labor because it had a shadow price of 16 more than the other one with 6. Now listen. Assume that, this is a final one. Okay. Assume that, and I like these questions. Assume fine yogo was rather 0 instead of 24. And we are talking about the final value. With a reduced cost of -5 and per unit profit of 40. And choco was 20 sachet instead of the 8 with a reduced cost of 0 and per unit profit of 90. Now, by how much would the profit contribution of Yogo has to increase before it will be profitable to produce it? Now, this is a very, very, we call it mental gymnastic question. And so I'm going to just use this section to just address it very, very quickly for you. According to the thing, fine yogo, all right? Fine yogo, the quantity of fine yogo is no longer the 24, but it's now 0. Okay, that's what we are told. It's no longer that. And then the reduced cost for it. The reduced cost for it is -5. And then choco is now 20. So choco, which was 8, is no longer 8, but is now 20. And then it has a reduced cost of 0. That's choco. But the profit contribution for choco, is 90. But that of yogo is still 40. By how much? You see, right now at this stage, I'm not producing fine yogo. I'm not producing. The question is saying that by how much? Let me just take you back to the question. By how much will the profit contribution of fine yogo has to increase? In other words, right now I'm not producing fine yogo. I'm not producing fine yogo, it's 0. But for me to be able to produce it, for it to be profitable to produce it, I must increase its profit contribution. Why? Well, if you look at the story carefully and what I just wrote, the profit contribution is what? Is 40. And I'm not producing it. So for me to be able to produce this thing and make it positive, by how much should the profit contribution be so that it becomes fun, enjoyable, profitable to produce it? How much do I have to increase it? Because for me to be able to produce this, it has to be increased. The profit contribution of 40 has to go up. By how much? Well, the best way to answer this is this. Please always note this. It is always the upper limit of the sensitivity bound. That's the answer. So you need to increase the profit of the fine yogo up to the upper limit of the sensitivity bound. Okay. And what is the upper limit of the sensitivity band for fine yogo? Do you guys remember? It was 60 something, isn't it? It was 66.7. Yes. So for me to be able to produce, because right now as it stands, it's not producible. So for you to be able to produce it, anyway, it is 66, but when you calculate this one, it wouldn't be 66. Okay, let me just show you right now. These are some of the beautiful questions, okay, that we were once upon a time given. And I'm going to just give you that. It's here. This is a question that you have been asked. So you can see that the fan yogo is 0, the choco is 20, the reduced cost is that, this is that. What is the upper limit? Okay, look at the upper limit. Okay, for you to get the upper limit, what would be the upper limit here? The upper limit should be 40 plus the 5, isn't it? 40 plus the 5. Good. That is how much you want the profit to be. Because right now, the profit of 40 is not buying. So the question is asking you that by how much should it be? So you just write 40 plus 5, which is the objective coefficient plus the upper bound of the sensitivity. Okay, how do you even write? Okay, the upper bound of the sensitivity limit. Okay, this is how it's supposed to be all the time for the thing to be producible if it is 0. If it is 0, okay, if it is 0, the value, the coefficient must be equal to the upper bound of the sensitivity limit. But how do you get the upper bound? Another way of doing it is subtracting the reduced cost from the upper bound, from the coefficient. Another way of doing it is the coefficient minus the reduced cost. That's another way of doing it. And the coefficient is 40. So it will be minus 5 because the reduced cost is minus 5. So another way of finding that answer is 40 plus 5, which again is 45. So it means that if I should now change this 40 and move it to 45, that is when the fan yogo no longer becomes 0, but it becomes producible. Wow, ladies and gentlemen, that brings us to the end of the entire caboodle. What a day, what a beautiful, what a joyful joy. What a way to wrap up the entire caboodle.